Children, now we are going to know the objectives and summary of the chapter number 5 of chemistry, states of matter. After studying this unit, you will be able to explain the existence of different states of matter in terms of balance between intermolecular forces and thermal energy of the particles. You will be able to explain the laws governing behavior of ideal gases. You will be able to apply gas laws in various real life situations, explain the behavior of real gases, and describe the conditions required for liquefaction of gases. You will realize that there is continuity in gaseous and liquid state. You will be able to differentiate between gaseous state and vapors and explain properties of liquids in terms of intermolecular attractions. So these were all the objectives of reading this chapter. Now the summary of the chapter. Summary. Intermolecular forces operate between the particles of matter. These forces differ from pure electrostatic forces that exist between two oppositely charged ions. Also, these do not include forces that holds atoms of a covalent molecule together through covalent bonds. Competition between thermal energy and intermolecular interaction determines the state of matter. Bulk properties of matter, such as behavior of gases, characteristics of solids and liquids, and change of state, depends upon energy of constituent particles and the type of interaction between them. Chemical properties of a substance do not change with change of state, but the reactivity depends upon the physical state. Forces of interaction between gas molecules are negligible and are almost independent of their chemical nature. Interdependence of some observable properties, namely pressure, volume, temperature, and mass, leads to different gas laws obtained from the experimental studies on gases. Boyle's law states that under isothermal conditions, pressure of a fixed amount of gas is inversely proportional to its volume. Charles' law is a relationship between volume and absolute temperature under isobaric conditions. It states that volume of a fixed amount of gas is directly proportional to its absolute temperature. V is directly proportional to temperature. If state of a gas is represented by P1, V1 and T1, and it changes into P2, V2 and T2, then relationship between these two states is given by a combined gas law, according to which P1 V1 upon T1 is equal to P2 V2 upon T2. Any one of the variables of this gas can be found out if other 5 variables are known. Avogadro law states that equal volumes of all gases under same conditions of temperature and pressure contain equal number of molecules. Dalton's law of partial pressure states that total pressure exerted by a mixture of non-reacting gases is equal to the sum of partial pressure exerted by them. Thus, P is equal to P1 plus P2 plus P3, so on. Relationship between pressure, volume, temperature, and number of moles of a gas describes its state and is called equation of state of gas. Equation of state for ideal gases, PV is equal to nRT, where R is a gas constant and its value depends upon the units chosen for pressure, volume and temperature. At high pressure and low temperature, intermolecular forces start operating strongly between the molecules of gases because they come closer to each other. Under suitable temperature and pressure condition, gases can be liquefied. Liquids may be considered as the continuation of gas phase into a region of small volume and very strong molecular attractions. Some properties of liquids are surface tension and viscosity are due to strong intermolecular attractive forces.